we see in this is it's kind of a metaphor for our own situation. The last tree could probably be observed somewhere from a high point of the island being cut down, and yet it was cut down anyway. These edifices took, the tallest were approximately 30 feet high, weighing up to 80 tons, and they took enormous amounts of lumber and rope to move in place, in position. And even as their construction destroyed the underlying sustainability of the economic system on the island, the Eastern Islanders did it anyway. They were determined to build more. And the thing about culture, and culture is something that as technical people we don't think that much about, perhaps, but we see it very much in the way we live, the way we operate our buildings, our commitments to energy efficiency or not, etc. Marshall McLuhan said, "We're not certain who discovered water, but we are certain it wasn't the fish." And culture is like water. We live in it, we can't see it. McLuhan also said, "First we shape our tools, and then our tools shape us." And we are, in a sense, creatures, prisoners of our own technical progress, if you will. Projected US CO2 emissions. Here we see primary energy end use by sector. The areas that we're looking at for energy efficiency really are all of those sectors, including residential, commercial. Those are the two areas we're looking at Laney College, preparing technicians to work in those areas. California is sort of at the center of energy efficiency because of our work, our investment in energy efficiency over a sustained period of time. Our per capita use of energy is lower. The other interesting thing about the whole energy field is that price signals, which are the dominant sort of element, are inadequate. If you look at these bars, you see that energy costs are relatively flat, so that people aren't getting a signal, gee, I ought to conserve, or I ought to learn how to conserve, and so forth. And now with shale fracking, we're getting a huge new supply of natural gas with some environmental consequences and side effects that we're only beginning to discover, radioactive water, etc. So this whole economic arena really leads us to the question of which questions to ask. How do we price oil, for example? Is it simply the cost of extraction? Should we be asking about our defense budget, our 450 bases strewn all over the world? Should we include some of those costs in the costs of oil? You know, as a society, we've chosen not to look at that. We've chosen not to include the whole vast structure that gets the oil to us as part of our equation of analyzing the cost of oil. Probably we oughtn't to do that. We ought to look at the whole picture. Another key concept that we've talked about earlier, net energy. And of course, the best watt being the watt that's not consumed. As I look at the situation and think about where we are and where we need to be on this, it's staggering. the level of change that's required to get from point A to point B. Unfortunately, it puts us into a regulatory arena because we need to affect externalities. For example, a lot of the cost of energy production and use is what we call externalities, and economists can't account for externalities. An externality is the cost of something that's transferred from the user to somebody else. And global warming itself is a giant externality of energy use and energy consumption with unknown economic consequences. One of the things we teach is social justice and environmental justice, and our students get very excited about that because very typically poor communities are ones that are where externalities tend to be transferred to, unfortunately. In any case, we currently have no way in our economic thinking to internalize these external costs and bring them into the energy cost equation. The policy context, many of you in California saw that our AB 32 was attacked in the last election by large oil interests. The whole policy context is really a struggle. It's a battle between big coal, nuclear, natural gas, and these little voices of energy efficiency, renewables, and so forth. So our future really hangs in the balance of how these political struggles are going to turn out. And unfortunately, they are the drivers of the labor market. They're drivers of the economic opportunities that will occur in these fields that we're talking about today, renewable energy and energy efficiency. Laney got quite a bit of ARA funding to work on prepare people for the residential energy efficiency market. Unfortunately, the funding mechanisms, including the PACE program that we anticipated, the bottom simply fell out. The mortgage banking community attacked the PACE program. PACE would have allowed homeowners to finance their improvements, either renewable or energy efficiency or both, through a first mortgage that would be attached to their property tax and amortized over 10 years. So that was a huge blow to this industry. We're actually seeing more traction locally in solar. In the Oakland area where we've been looking, there are literally thousands of what we call shovel-ready projects. In other words, homes. Homes and buildings share one thing very much in common. That is, neither are particularly well maintained. Homeowners tend not to maintain their homes much at all. And buildings, the first place you cut is the maintenance department. There's a lot of movement now in the commissioning field to re-engineer buildings. In other words, they were never operating well in the first place, so we really have to start over and re-engineer them. And here we see some of those issues laid out. Energy efficiency, again, is intangible, difficult to explain, and relatively invisible. Okay. One of the things that we've been focusing on a lot in our curriculum is the sales piece. We have to teach economics and sales to our technical students so that they can better understand the relationships and ultimately sell these concepts, difficult concepts, to homeowners and building operators. So we have conflicting business models. I'm just about out of time, so I'm going to zip through these. Somebody talked about designing sustainability in, and that's really what we need to be doing. Unfortunately, most of our built environment is already built, so our opportunities to do a lot of rebuilding are pretty limited. And that leads us back to retro-commissioning, re-engineering, energy auditing, weatherization at the residential level. And here are some of the job categories in this field. And I think what I would comment here is that the level of skill required by technicians today, especially in the building sector, commercial building sector, is much greater. And there's a transition in the buildings themselves. There's a transition in the way in which technicians operate. There's a transition in the way building owners view the buildings and the way in which they're managed. All of these things go together. We can't simply train building technicians without these other pieces moving along. But I think there is an increasing awareness of the importance of sustainability in building operations. So there you can see some of our challenges, and you'll have to take a look at this yourself later. You can see the range of technical skills that we've identified in our teaching to in our curriculum for building operators, which we call knowledge workers of the future. This is a commercial lab that we've built at Laney. This is a plastic house that PG&E donated to us. This allows us to teach our students about backdrafting and combustion gas and pressure and the relationship between these things in the house. And we have some website resources there that you'll find. You can find our curriculum laid out. You can also find a copy of our study, which is very rich, and I highly recommend it on current building operations. Thank you.